Dui Zhang. She has almost submitted her PhD thesis, and she is working as a research fellow in a modernized human slavery project, where she's applying all these language models, Gen AI models, to find out which documents of the government in Australia, in Canada, and UK satisfy to these modern slavery statements. I can proudly say that she's one of my best PhD students. During her candidature, she published 2 D1, 1Q1, and many more, a few conference papers, and some of them under review. And these are very high impact and very low acceptance rate. So it's outstanding for a PhD student to publish in these journals. In addition, she ran a tutorial in PAKDD, that is a top quality data mining conference on multimodal learning. And I hand over this to Dui. She would introduce herself in more detail and about the module. So as I said, we have provided you many Python notebooks. So she's going to go through them and explaining them how it works. So all to you, Dui. Thank you.
Thanks, Richie, for the introduction. And for this tutorial, we are going to discuss this discriminative and generative classifier. As Richie introduced, my name is Dui Zhang. I'm the speaker of this tutorial, but the code and also the slides are co-contributed by Sharon Toro Pingi. We are from Advanced Data Science and Machine Learning Research Group from Queensland University of Technology. So before we start, here is a disclaimer. These slides have been prepared and for the course Gen AI and Use Cases delivered to Indian Faculty of Engineering and Technological Institutions under the EICT Academy program. The results from extensive research and years of hands-on experience in this field. Please do not use or reproduce the slides or their content without the explicit permission of the author. This applies to all slide decks and material delivered under this 40 hours course. So because most of the scripts are contributed by Sharon Taro Pingi, so Sharon is a nearly finishing PhD student at QUT. Actually, I think she submitted her thesis just yesterday. Her topic is at the intersection of deep generative models and longitudinal data analysis. She is passionate about her work in developing innovative models that address data-level challenges like missing values and class imbalance to enhance the task of early classification in longitudinal datasets. Her work empowers timely decision-making across multiple domains, including health and education. Here are some selective publications from Sharon, and actually they are all relevant to our topic of this tutorial. I will explain them maybe later. But next week, there will be a GAN lecture for, I think, certain papers. So for this tutorial, all the materials are generated from this one, a comparative look at the resilience of discriminative and generative classifiers for to missing data in longitudinal datasets. So if you find this tutorial useful for your research, please set this work. As for me, I'm also a nearly finishing PhD student at QUT, and I did my master at University of Melbourne in IT, and I finished my bachelor degree at University of Science and Technology Beijing in China. For my PhD thesis is about multimodal representation learning, deep learning, uncertainty-based methods. My research interests are uncertainty-based approaches, gating mechanisms, NLP for application, and also multimodal learning. Here are some selective publications. So all of them are relevant to multimodal based classifiers, and they are actually discriminative models. For the tutorial, I had a tutorial together with Professor Richie Nayak and Dr. Andy Abou-Bashar about multi-aspect learning, issues, algorithm, and application. If you are interested in these kind of topics, feel free to check these tutorials. And I have conducted the 6-month internship at Telstra, which is an Australian telecommunication company. Okay, now let's go back to this tutorial. The goal of this tutorial is to compare the discriminative and the generative classifiers. The aim is to address the challenges of classification tasks with missing values in datasets. And we will go through lots of deep learning-based methods and also quickly go through some machine learning-based methods for this kind of topic. So for the deep learning-based model, we will check this LSTM-powered discriminative model, CNN-based, and also fully connected layer-based discriminative model. And we will also explore this GAN enhanced LSTM, CNN, and fully connected layer models. So GAN is a foundation generative model, which we will explain in next week. But this week we will check how this GAN model is implemented and how it uses a backbone method such as LSTM, CNN, FC for building the model. And we will explore integrating methods for handling missing values to improve prediction performance. So for this work, we don't actually use imputation to handling the missing values. So for those who are not familiar imputation, so imputation is a method like generate some like meaningful results according to the current evidence using methods such as generative AI. And instead, for this work, the missing values are represented as -1. So our assumption is that this kind of -1 contains actually informative information, which I will elaborate in the later slides. And also this kind of method is much easier for us to implement the code for the purpose of comparing the discriminative and the generative models. If you are interested in generative-based method for imputation, please check this work of Sharon's. So in this work, she used a GAN model to impute the missing value of longitudinal data and also conducted the classification task. So in other words, the generative model not only do the classification, but also do the imputation. So the expected outcome of this tutorial is to develop robust deep learning methods that can handle missing data efficiently. We will compare different kind of models' performance, such as the discriminative model, including LSTM, CNN, and also the generative models, such as GAN-based LSTM and GAN-based CNN. We will also get some insights into the impact of missing data handle. During the experiments, you will see how this kind of discriminative and generative method handling this kind of missing data and how the model performs with this kind of method. And oh, someone mentioned I'm not that audible. So let me.
You are audible,
Okay.
but little bit faint, but it's quite audible. I think the person who asked can increase their audio volume. It
Okay.
might not have increased their audio volume. So Dewey, you can go ahead.
Okay. Yeah. Okay. Thank you. So I will introduce the type of data later, and we will actually have one notebook to check the data set. So and the final outcome would be a framework for practitioners to apply deep learning methods on different kind of longitudinal data sets with this kind of implement entries or missing values. So here is the agenda of this tutorial. I'd like to first introduce the dataset we are going to use, and we will also give you some time to set up and install relevant softwares like Python or also some libraries like scikit-learn or PyTorch. So the first notebook is about data exploration. The purpose is to get familiar with the longitudinal dataset and understand the structure, feature, and also our target variables, which is the label information. And following that, the notebook 2 contains some machine learning based methods, such as some generative classifier, like the Gaussian mixture model, and also a discriminative machine learning model like the XGBoost. The goal is to gain more insight into the longitudinal data and how it performs classification. And then following that, we will focus on these notebook 3 to notebook 5. So they contains different kind of discriminative methods, including this kind of fully connected neural network, LSTM-based method, and also CNN-based methods. So we will go through the optimization process and how we build the model for these 3 backbone network separately. So don't worry if you are unfamiliar with PyTorch or deep learning. And finally, we will focus on these generative adversarial networks-based methods. So for this GAN method, it will use the previous 3 kind of methods as backbones to build the generator and also the discriminator. So we will explore how it different from the previous discriminative methods. So for deep learning frameworks, right now there are 3 popular deep learning frameworks, including TensorFlow, PyTorch, and Keras. For this tutorial, we are going to use PyTorch. Actually, I think for most of the deep learning research work, they are based on the PyTorch, including the baselines and also other specs. So it is quite generalizable in the research domain. But if you are from industry, you may get familiar with these TensorFlow or Keras, which is a high-level API to build the deep learning models. So to run the scripts, you might need a Python version higher than 3.9. For me, I'm running it on Python 3.12. Alternatively, you can upload everything, I think, to Google Colab. I haven't tried it on Colab yet, but it should work. So we will need the Jupyter notebook. So please install this Jupyter notebook through the pip command, or you can directly open it in Anaconda if you have one. And for the Python libraries, I think most of the libraries are quite generally used in the data mining domain, like the argparse, inspect, numpy, pandas, and also these warnings and the YAML. And for the machine learning and the deep learning frameworks, please install these PyTorch from the website according to your system setting. We will also need scikit-learn to run notebook 2 about machine learning methods. And please also install this XGBoost for notebook 2. So now we will give you like 5 to 10 minutes to install all the required software and also the packages. Yes, you can work these on Google Colab. Actually, I think Colab is much better. I think I will copy these requirements in the chat so you can follow them.
Yeah, while Dewey copies it, if you have got Anaconda, it should work because just the Python notebooks that we got, they are part of Anaconda. So you just have to make sure that you have that notebook tab on Anaconda. So if you got Anaconda installed, you don't need to reinstall. So we are giving them time to make sure that they have these pre-requirements specification met, or install these requirements if you don't have it.
If you don't have it, please install these requirements. And please let us know once you've installed all these kind of libraries on your side. Yes, you can upload all the scripts to Colab to work on it. Yeah. One participant mentioned that if you work on Colab, then no need to install all of these. And for these experiments, I don't think we need GPU resources. So it will be a longitudinal data set. It's not that as complex as the image or the NLP domain. So you can run it with CPU, I think. From my side, I run it on CPU and it works very good and quick. So if you have Anaconda, you might need to install, I'm not sure like your environment. So probably you need to install pandas and NumPy, but I think for most of Anaconda environment, it comes with this kind of packages. And maybe the XGBoost, because it's not built in with the, I think, Anaconda environment, but I'm not sure about these.
I'm so sorry that if you are having any installation problems, I'm not sure how we can help. But what I suggest that you can try later on. So in today's tutorial, Dewey is going to explain the codes and we'll show that how it is run in our environment, and then the results. So you would understand what these codes and how, most importantly, how these Gen AI models work. Otherwise, yeah. So it's good if you are able to manage the environment where these codes can work. If then you can practice with us. If you can't, then don't worry too much about it. You can do it in your own time. But today, then Dewey is going to run through those notes, run through the results, explaining how these models work.
One participant asked if they can get the files. I think these files supposed to be shared at some place. Yeah. Okay. Thanks for confirming that.
In this course, we have used multiple data sets. Some of the data sets, if we are not providing the copy, it means that data is not available. It's a proprietary, and we are using it for the demo purpose. But then there are other data sets that you can use for the experimental purposes. So as I said in the lecture, that most of these works have been deployed in the industrial scenario. So some of them are proprietary. So we are showcasing how they work, but we are not allowed to share it. So in that case, we would have some other data sets, like in today, Dewey talks about that data, but then shows how it works with using other data set.
I think the early school leavers data set has been included in the, oh, sorry, yeah. So it's a pre-processed version of that one. So yeah. So how's the progress? Like, has everyone finished this installing these pre-requirements? Okay.
Let's take a couple of more minutes before we start, so everything comes on that part. And I think Dewey is also timing, so she has got some estimation in terms of how long she wants to wait.
Okay, so I think I will use this time to double check the resources we have shared with the participants. So can everyone see this screen? It's a directory. So within this directory, we shared 6 Jupyter notebooks. So notebook 1 to notebook 6, and several like modules like data prep and Logan CNN, Logan FCN, and also parameters utils.py, and and also this ESL ready dataset. So does this align with your does this align with the code you got?
So in this tutorial, we are using 2 data sets, ESL Ready, that is a proprietary data. So we are giving you much more compact version of this data set. And then another data set is Oasis, and we call them ESL Ready and Oasis Ready because they have been pre-processed. They are not raw data set. We have to do a lot of pre-processing from raw data set to reach in this version. So these are the data sets ready for this particular model to be used. So our main focus in this module is how these GAN models have been used on this kind of data, but not really on data pre-processing.
I think we can move on to the next section. Yeah. Okay. So I will first briefly introduce the background of this dataset, and following that, we will run notebook 1 about this dataset. So
before just Dewey goes onwards to the participants, we are the delivery team, so we are not aware that how this information is shared and things. So I think that is the differentiation. You need to contact the local host to see how you get that information. So as a delivery team, we are delivering this lectures and this content that we have prepared, and we are delivering it. How that, unfortunately, we don't have too much information.
Yeah, thanks, Richie. So for the longitudinal dataset, it is multidimensional. It contains two, which I call them modalities. The first one would be the temporal modalities, and which means the variables within it are not IID, identical independent dependencies, things like that. And the other modality is the static modality, which are the covariance effect, temporal observation, and the correlate with the outcomes. So static modalities contain feature like the demographical information, and the other informations which we are probably collect prior to the temporal modality for some certain cases, but for other cases, but it all depends on your using scenario. This may not always the case. And regarding the relationships between the temporal and the static features, please refer to another Sharon's paper, which discuss the correlations with the static and temporal modalities and how their interactions affect the imputation and also the generative classifier. Another characteristic of this longitudinal dataset is heterogeneous. So heterogeneous means that it carries the variability of the participants. So you will see in notebook 1 that for each data or each instance, it represents one individual, for example, one student or one patient, and the data for them collected from maybe ICU department or by the education sector. And the last characteristic is irregular sampling and dropouts, which means it contains certain percentage of missing values, and it can potentially decrease its classifier performance according to previous literature. And sometimes the missing values have certain pattern. An example would be, for example, the longitudinal data collected from the ICU, and after a certain time step, for example, for heart rate, the values are all -1 for each time step. That probably means the patient has discharged from ICU. So for this ESL dataset, it represents the early school leavers. It contains 35 student records over 11 schooling years. And the label represents whether the student dropped their study before completing year 12 or not. And during the pre-processing process, Sharon has did several pre-processing methods to refine this dataset. So the version now you are getting is already been processed. Here we just introduce how we pre-process this dataset. Like we remove the duplicate, leaky, and the zero variance variables. And for continuous variables, we rescaled it between 0 and 1. For categorical variables such as gender, we transform them into one-hot encoding format. And given that the first 6 years of the schooling information had only 10 to 20% of the time variant variables, these time points were omitted from the study. As a result, the cleaned version, which is the one you are having, the ESL ready dataset, has 35 static variables, which we will check later, and 8 variables. So those 8 variables are temporal features. Each variable has 5 time steps. And the dataset is highly imbalanced with only 7.24% of positive samples, indicating that the student dropped prior to year 12. Now let's have a look at this notebook 1. The purpose of this notebook 1 is to focus on providing some overview of this dataset. We will get familiar with the structure of this ESL dataset, and we will understand the existence of missing values for the longitudinal dataset. Now let me change my screen to the Jupyter notebook. So it will be this one, dataset demo. So I'm going to explain this notebook block by block. The first block here aims to load this ESL ready dataset, and we are going to use this pandas package. So in case you are not familiar with Python, so pandas is a library that handling the tabular data. For our longitudinal dataset, we store them into a CSV file. And here I print out the top 5 records from this dataset. So we can quickly check the format of this ESL dataset. So it's stored in a tabular format, and we will convert them into the proper format later and also in the experiments. So the second block here is the overview of this dataset. For this dataset, it contains 35,000 approximately instances, and each instance is presented as a row of this dataset. For example, here, number 0 represents 1 student, and for the columns, it represents the features from the dataset. For example, for this number 0 student, the math enrolled by Feb year 11 is 0.2. Keep in mind we have rescaled this result, so that's why it's 0.2. And for their gender is 0, so things like that. Here I print out all the features. So there are total 76 features for this data set. And because it's a longitudinal data set, we are going to reformat into static information and the longitudinal information. So the reason we split them into 2 different kind of modalities is because we may use different kind of neural networks or strategies to deal with them because of the characteristic of these 2 modalities. Now let's move to the third block. So here is how we actually transformed the original tabular data into the static and the temporal modalities. In the preprocessing step of the following code, you will probably observe something similar to it. And here the purpose is to check the static features and the temporal features. So the label, for the label of this data set, it is the last column of each row. For example, for the first instance, the label is here, the ESL flag, which is 0, which means that student number 0, they didn't drop the course before year 12. So that's the last column. And as for the static feature, the first 35 columns represents the static feature, contains the static features of our dataset. Once we print, it's supposed to be something like this. So it contains demographical information, including gender, indigenous status, and the OOHC flag, and also other information. And because as we mentioned in the slide, there are some incomplete information. So for example, for year 7 reading score, we don't have maybe year 9 or the following years. So we don't want to waste this kind of information. Instead, we treat them as the static information over here. So this kind of splitting is all depends on your design of the model, and may potentially influence the model performance. As for the temporal features, They are the number 36 column till the last second column of the tabular data. Here we reshape it into 5 to 8, so 5 time steps and 8 variables. As you can observe from this temporal feature over here, so for example, the first variable is the total absence. We have the total absence of year 7 and also year 8, year 9, year 10, and year 11. That's the first variable. Following that is the second variable, is the attendees of year 7, year 8, and till year 11. So things like that. And finally, the last block over here aims to introduce the missing values within the dataset. So the purpose here is to show how challenged this dataset is given the proportion of missing values. So missing values are imputed as -1 here. The reason is that for static features and also temporal informations, so they are all scaled beyond 0, which are meaningful maybe in the real life scenario. So that's why we select -1 here to indicate the missing values. And here I summarize the proportion of missing values for each feature, as well as the proportion of missing values for this dataset. And as we can see over here, lots of the temporal features has this kind of missing value, and maybe also for some static features. So that's all for this notebook 1. So feel free to check this notebook 1, and I think I will pause here and give you like 10 minutes to run it at your site. If you haven't finished installing all the requirement libraries, you can use this time to do that as well. Is it better, like after you mean?
So there is a question in terms of static and dynamic. So you should not be thinking it as the question is, if year 7 has a value, year 8 missing, then 9 to 11, then 9 to 11 becomes dynamic. No, you should think about it as a time series data and demographic data. So demographic data like ethnicity of the student, parents' income, and so on, they are demographic